The Make Noise Contour is a flexible 4-stage function generator derived from their popular zero-coast synthesizer. It allows users to create, shape, and output a broad spectrum of control voltage signals. From multi-stage variable response ADSR envelopes to CV adjustable LFOs. The onset, sustain, and decay knobs mold the contour's output. And the vary response knob refines the impact by smoothly transforming its response curve from linear to exponential. Additionally, there's an assortment of control voltage inputs and outputs, including an end-of-cycle output, which can be used to quickly transform the contour into an effective low-frequency oscillator. Add external CV to the onset and decay times, and now you've got an excellent modulation source with a wide range of possible wave shapes. To begin, patch a CV gate source from a sequencer or keyboard to the gate input. For this example, I'll be using the contour's output to control a fast VCA. Set all 4 knobs to their lowest settings, which is fully counterclockwise. Start sending gate signals, increase the level of the decay envelope, and the VCA will begin to open and close in response to the contour. Decay determines the length of time it takes for the envelope to decrease to the sustain level, which is currently set at 0. Now slowly begin to increase the onset level. As the onset level becomes higher, the time it takes for the sound to reach its maximum level increases. This is commonly referred to as the attack component of an envelope. Using just these 2 controls, we've got a perfectly functional 2-stage envelope. But notice how the shape of the envelope is linear. It's a straight rise and fall. The vary response panel control can transform this linear response to an exponential curve. Increasing the vary response causes the onset stage to rise at a quicker rate, and the decay stage to fall more rapidly as well. This results in faster sounding envelopes, useful for developing more percussive sounds. Turn it back counterclockwise, and the envelope begins to straighten out again. Both the onset and decay parameters have a corresponding CV input, so it's possible to modulate either via external control voltage. Increasing the sustain will set the level at which the envelope will remain for the duration of the incoming gate. The onset still controls the attack time, and decay still controls the amount of time it takes to reach the sustain level. But the sustain level is no longer 0. Therefore, we now have an envelope with more than 2 stages. The decay control actually has 2 jobs. It sets the time it takes to go from the maximum to the sustain level, but also the amount of time it takes for the sustain level to reach 0 again after the gate signal goes low. This is generally known as the release time. Now we've got a practical, pliable 4-stage ADSR envelope. A mirrored version of the resultant envelope is available at the jack located to the left of the main output. The EOC, or end-of-cycle jack, activates a gate signal at the end of each generated envelope. This can be used for triggering just about anything, including the contour itself. Patching the end-of-cycle to the gate input conveniently turns the contour into a CV-controllable low-frequency oscillator. Adjustments to the onset, decay, and vary response knobs will alter the speed and shape of the LFO. The EON, or end of onset output, sends a gate signal at the end of the onset portion of the envelope. This can be used for a variety of purposes. For example, I've patched the EON to a random voltage generator, which is patched back into the decay CV input. The end of each onset now triggers the introduction of a new random voltage level, resulting in a randomly selected delay time for every received gate. The focus here has been on using contour as a tool for controlling a VCA, but that's really just the beginning of its creative potential. It's more than capable of producing an extensive variety of single-cycle and looping envelopes, which would be ideal for modulating filter cutoffs, oscillator pitches, clock times, LFO depths, and much, much more.